He is a reviewer of many internal journals and international conferences. He has been at conference session chair at IEEE conferences in Malaysia and various other reputed conferences. He has in total 15 publications to his credit. His field of interest is wavelet transform and other signal processing tools, application of artificial intelligence to power system, and Weld image segmentation and classification. His today's piece title is Application of Artificial Intelligence to Fault Location, Weld Image Classification, and Prediction of Air Pollution. Over to you, sir.
Thank you, Ishika. Thank you so much. And thank you very much, Dr. Bhadoria and Ishika and all the participants of the LDP for bearing with me for the technical glitch. So I humbly extend my sincere apologies for the technical glitch which has happened. Now, without wasting a single time, let us start to the interesting topic of application of ANN to image classification, power system faults, and prediction. Now, I have been introduced. So ANN is what you say, it is in the present scenario, artificial neural network is an information processing paradigm that is inspired by biological nervous systems. So as my title has suggested, I will be covering three topics right now. Image classification, that is 2D, two-dimensional power system faults, that is one-dimensional, and prediction. Here by prediction, I mean the current scenario, the people living in Delhi NCR and around the globe facing the hazardous pollution. That prediction what I have done my work, I will be sharing you the three incidences. So my application of ANN is now extended to three things. Number one, it is to image classification, power system faults, 1D, and prediction. So as I discussed, what is ANN? ANN is an information process paradigm that is inspired by biological nervous systems. Analogy to our human nervous systems, ANN was developed by our scientists. So as you have the nervous systems in your body, which are responsible for transmitting each and every data, whatever body needs to other sources. Similarly is the nervous system, similarly is the conceptualized, developed for ANN. Now it is composed of large number of highly interconnected processing elements called neurons. Neurons are nothing, they are the carriers which carries and transmits the data. In our analogous to human body, if you want to drink water, if I raise a hand, right now I'm speaking, the signals are being sent to the brains that what words I should speak. So an ANN is configured. Now you can, as per your desire, you can configure an ANN for applications such as pattern recognition or data classification. Next slide. So let us now discuss about the origin of neural network, how it was discussed and what is the origin. So human brains has many incredible characteristics, as we know, massive parallelism, distributed representation and computation, learning ability, generalization ability, adaptability, which seems simple but is really complicated. You know, a human body, we have developed the computers, we have developed the mobile phones, we have developed the technology. Lot of human brains and a lot of neurons going, and lot of things are going in our brain. We are discovering things. So this is our human brain, the numerical chain chemical reactions going in our body. So it has always been a dream for a computer scientist to create a computer which could solve complex perceptual problems very fast. We need some mechanism, because as a human body, we have developed the mechanism, we have developed the tools, but there still exists a need so that a complex perpetual problems can be solved. So ANN models was developed in analogy to the human structure to apply the same method in order to solve the perpetual problem. Now this is the history where how it was developed in 1940. McCulloch and Pitts, they had the initial work of the neural network. Then Rosenberg had developed the perceptron convergence theorem. Later on, Minksy and Papert had developed the limit. They have worked on the limitations of simple perceptron. In 1980, the Hofeldt energy approach or the back propagation algorithm came into picture. Now, this is the structure of a biological neural network. This is the nerve. This is the nervous system of our cell. These are the axons which carries the signal. This is the nucleus. This is the center. This is the memory. These are the cell. These are dendrites. Okay, which carry the signal in axon carries the signals. These are the signals. Suppose I want to speak about the biological neural network. So dendrites in my body are actively giving the nervous system, go. Dr. Pratul wants to speak something about the FDP. Now, once whatever I'm speaking, now this is being transmitted away by the axon. Now synapses change. So synapse size changes in response to learning. How whatever we want to learn, the size becomes for churning. So since we are an engineer and we have representation of the human neural network in simple technical and mathematical form, you can learn from this diagram. See, it takes the input x1, x2 till xn. There can be numerous input. If I want to speak about neural network, I want to speak about my work, I want to speak about Weld images, I want to speak about the FDP, how it is being conducted on Microsoft team. So there were right now for almost 40 minutes, there were technical glitch. Many things are going, I will go there, I will go somewhere because I have to conduct a session. So in all these cases, the inputs were taken. So you can have n number of x. So all these input, it is proposed in the neuron where you calculate the summation, whatever we want to do. And we compare with threshold for the learning stage. Here we learn it. What are the actions which should be taken at first? I should speak or I should think or I should do, what is the processing should go. And then it is the output which is being developed. So it is simple, the summation of all the actions required for getting the derived output. So we have this biological neural network being termed in the mathematical model. Now, I told you, learning is one of the major criteria. It is one of the major factors which is responsible for carrying out the network, for carrying out the process of neural network. Because learning is one of the, without learning, you can say that learning is the main mechanism which helps us what we want to get for. So learning in a technical term is the updating the network architecture and that which connects weights so that network can perform any task. Net weights means you are updating the neurons. So there are different patterns available for different set of mechanism. There are different patterns available in order to achieve different, you can say, different set of patterns or different set of targets what you want to achieve. So for this purpose, different available patterns are there. This is the ability of ANN to automatically learn, and examples from the input-output relation. Whatever input you are getting, you have the particular training pattern which will deliver you the given output. In other words, you can say ANN is a black box. Black box, it is available in the airplanes everywhere. So ANN is the black box from where you can transfer a data, you can process it as desired into the other form. Now designing as we know, learning is you can say it is the most important paradigm. It is the most important structure. लर्निंग ऐसा चीज है जिसके बिन जैसे आप लर्न करवाओगे न्यूरल नेटवर्क को, आपको वैसा आउटपुट मिलेगा. So learning is one of the prominent feature of the neural network. So learning paradigms having a model from the environment, number one. Figuring out, then you have to define some rules. Like Dr. Bhadoria defined, no, sir, first we will have your introduction, then you can proceed. Similarly, in this pattern, you have certain rules needs to be defined so that to carry forward any task. Suppose there was a technical glitch. Actually, glitch was the Windows administrator was not allowing for the connectivity for this Microsoft team. So I had to unbound, I have to unveil all those, I have to just disassemble this security, then I have connected. So the set of rules have been defined so that we can update the process of weights on neurons. How many neurons you want, the weights can be updated. So we have to identify a procedure. So adjust the weights by learning rules means updating the weights and using the rule is known as the learning algorithm. Anything in the world. Right now, you are working on computer. You are listening to my FDP. You are listening to my lecture. You are listening to anything. There has been a strict certain pattern, certain algorithm which has been derived on which the whole process, the whole atmosphere works. So a procedure is, you have to identify a procedure to adjust weight by learning algorithm. So there are, based on this learning, we have this, the learning have been divided into different supervised learning, hybrid learning, unsupervised learning. Hybrid, combination of supervised and hybrid. So what is supervised learning? Supervised learning is one which incorporates an external teacher so that each output unit is told what its desired response to input signal ought to be. Means everything, the the hidden layer, or you can say we know the neural network has basically three layers: input layer, hidden layer, and output layer. In supervised learning, in order to get the desired output, every input signal which is being fed to the system is being monitored. मतलब आप जैसे माइक्रोसॉफ्ट टीम, अभी आप लेक्चर ले रहे हैं, अभी हम लेक्चर ले रहे हैं, अभी आप एफडीपी सुन रहे हो, तो एआईसीटी हैज डेवलप्ड कि अगर आपको AICT has developed a paradigm. AICT has developed a model that you have to register in Atal FDP. अगर आप register करोगे Atal FDP में, then you can explore for this supervised learning. So supervised learning incorporates an external teacher with each input is told and desired response to the input signal is out. Now, during this learning process, global information will be required. What is this global information? What you want from the scenario to get the desired. आप क्या चाहते हो surroundings to fetch the result. That is the global information. The paradigms of supervised learning includes error correction learning, reinforcement learning, and stochastic learning. There are the different learnings. And if you want to, there are basically, if you see in power system faults, basically mean square error. We keep on getting the error until the convergence, the optimal convergence curve is required. Or reinforcement, we put on reinforcing thing. Now we want this. And the stochastic, you can say you can add anything for stochastic learning. So important issue for concerning the supervised learning is the problem of error conversion right now, which I mentioned right now. Convergence, because if your algorithm, if your parameters converge, then you will get the desired result. आपने conversion पढ़ा है, load flow में पढ़ा है, हर चीज में आपके जो parameters है, it needs to be convergence. That is the minimization of error between the desired and computed unit value. Convergence क्या है? वो दोनों के error, मतलब difference, जो आपका output होना चाहिए था और जो आपको आउटपुट मिलता है, उसको आप जितना कम कर सकते हो, whatever by using whatever algorithm you are able to bridge the gap between the algorithm, then you are going to get the desired and error convergence. Well, the aim is to set a weights in the supervised learning which minimizes the learning. I told you, you have only one basic color, the convergence, मतलब जो आपको आउटपुट मिलना चाहिए था लेकिन आपको क्या मिल रहा है, उसको जितना उन दोनों के बीच में एरर जितना कम हो जाए, that is supervised learning. So here I told you before only when I was addressing this, least mean square convergence is used for the training. Now this has the application in power system faults or prediction. Now second type of learning is the unsupervised learning. Unsupervised learning, no supervision, nothing is there. Whatever input you get a desired output. So So no external teacher, it is based upon only the local, whatever local information. It works on the local minima, the locks on the local boundary condition. So whatever local information you have, the unsupervised learning works on it. It is also referred as self-organization in the sense that it self-organizes the data presented to the network. ये अपने आप डाटा को ऑर्गेनाइज कर देता है in order to fetch the output and detects their emergent collective properties. Now next, so neural network, I can categorize, you can say, just summarize, it is the behavior of an artificial neural network. It depends upon the weights, that is the neurons, the input-output function, that is transfer function, that is specified for the particular units. Now, functions can be three categories. It can be linear, it can be ramp, it can be sigmoid. It depends upon the functions you are taking. Now, for linear inputs, linear units, means if you want a linear curve, the output activity, as the linearity says, the output activity is proportional to the total weighted output. For threshold, where you have to determine the threshold beyond which the work will happen, the output is set at one of the two levels, depending on whether the total input is greater than or less than the some threshold value. After that, you have to do how many inputs you are taking. Considering all the inputs, it should be greater than or just immediately less than a particular weighting beyond which you will get the desired output. And for sigmoid units, we generally tend the tag sigmoid, the output varies continuously, but it does not vary linearly as the input changes. Sigmoid units bear a greater resemblance to real neurons that do linear or threshold units, but all the three must be considered through rough approximations. In sigmoid is that's why the sigmoid member function, or you can say the sigmoid unit, what the is function is usually typically used because in general structure we will use the neural network or we will go into these paradigms if there is some complex problem. अगर आपके पास कोई complex problem नहीं है तो आप क्यों करोगे? तो आपके पास in order to solve the complex problem आप sigmoid structure ही लेते हो for getting the solving the complex problem. और जितने भी आप datas हैं. Now here you can see feed forward networks have one-way connections from input to output layers. आप देख सकते हैं and जो हम use कर सकते हैं basically feed forward, there are basically feed forward back propagation, and you have all this. I'm just covering a basic structure to give into detail. These feed forward networks have one-way connection from input to output. एक connection input से output की तरफ जाएगा, and they are most commonly used for prediction. कोई चीज को प्रेडिक्ट करना है कि 10 दिन बाद हमारा वेदर कैसा रहेगा, 10 दिन बाद हमारा एयर पोल्यूशन कैसा रहेगा, पैटर्न रिकॉग्निशन. मान लो आपका सपोज यू हैव साइन समवेयर और सपोज you are using the biometric. So while designing the biometric, the pattern needs to be verified. Okay, if there is so much n% of tampering in your finger network, it is permissible, beyond which there will be problem. So, and non-linear function fitting. For the fitting of non-linear equations, आपका feed forward network we use. The supported feedback network includes feed forward back propagation, cascade forward back propagation, feed forward input delay back propagation, linear and perceptual model. These are the basically derivatives, or you can say the examples of feed forward networks. Further, the radial basis networks provides an alternative fast method for designing non-linear feed forward methods. This is another type of network which is being used. Supported variations include generalized regression and probabilistic neural network. Now, dynamic networks. There are another dynamic networks. The first was feed forward, then radial basis. With the evolution, the dynamic network came. They use the memory and recurrent feedback connections to recognize spatial and temporal patterns in data. वो डाटा जिसमें टेम्पोरल पैटर्न्स, उनके पैटर्न्स की आज जैसे आप वेदर फोरकास्टिंग करते हो, दिस इज द टेम्परेचर टुडे, दिस इज द टेम्परेचर इन सितंबर, दिस इज द टेम्परेचर इन अक्टूबर, दिस इज द टेम्परेचर ऑन 25th अप्रैल। तो उन सबको कोरिलेट करके व्हाट विल बी द टेम्परेचर एप्लीकेशन और व्हाट विल बी द टेम्परेचर आउटपुट यू आर गोइंग टू गेट, you can go use the dynamic networks for that. Up right now everybody is using all the applications in your mobile phone. I agree. You have accurate weather, you check the Google weather, but how do they predict? They are predicting, they are collecting the millions of data of the previous years, they are analyzing it, they are using in putting in ANN, and then they are predicting it कि अब आज लास्ट ईयर दिसंबर में 2019 में ये टेम्परेचर था, 2010 में ये टेम्परेचर रहता है, 2000 में ये टेम्परेचर था, 1900 में ये टेम्परेचर था. So based on all these examples, you are going to get what can be a temperature on 18th of December. You are very familiar with the news कि आज ठंड ने 20 साल का रिकॉर्ड तोड़ा, ठंड ने 80 साल का रिकॉर्ड तोड़ा. How? Because if your day December came from long ago, whatever data is being available with us, whatever data is being monitored with us, these are used for prediction जो आप accurate weather और उसमें देखते हो. So dynamic network use memory and recurrent feedback corrections to recognize spatial and temporal patterns. They are usually, see what I have told you, they are commonly used for time series prediction. जो मैंने बताया, आज कल 25 दिसंबर को वेदर क्या रहेगा, 1 दिसंबर को वेदर क्या रहेगा. So you have to use this dynamic neural network. They are usually used for time series prediction, non-linear dynamic system modeling, control system applications, pre-built dynamic networks in the toolbox. If you use the MATLAB toolbox, which we have been using, include focus and distributed time delay, non-linear autoregressive, layer recurrent, Elman and Hopfield network. These are the different networks. So let us have a look on the diagram. These are the connection pattern, feed forward. What is input? The hidden layer, all input is given. The input is given to all the layers. This is the basic structure of a neural network: input, hidden, and output. So whatever is given there, input, these are the inputs, these are the hidden layers where all the process of input takes place. And what is the optimal solution for the output you get? You get in the desired output. And in the recurrent matrix, again, you can say you are getting two outputs. The output is again fed to the hidden layer for further analysis to get the optimal y1, y2. Here, you can say x1 to xn is the n number of input that is there. Hidden layer is h1 to h1. Suppose it is a 2 layer, it is a 4 2, you can say 2 or 4. So here Z1, Z2 is the output, and for the different predictions, you are getting this recurrent neural network. So basically in our work, in our research work, what we have done, we employ two types of neural network. That is, first one is Levenberg-Marquardt neural network. Levenberg-Marquardt neural network. So this was independently, it was developed by Kenneth Levenberg and Donald Marquardt, which provides a numerical solution to the problem for minimizing a non-linear function. It is fast and it has a stable convergence. That means the error between the final output which could have been and the desired output is very less. In the artificial neural network field, this algorithm is suitable for training small and medium-sized problems. Now we will learn about the application later on in the presentation. So in order to solve nonlinear least square problems, LMA is used. This is a short form. Levenberg algorithm is used as a standard problems. It is a combination of gradient descent and Gaussian Newton method which appears in this algorithm. You have to find the Jacobian matrix, and by Jacobian matrix, it is calculated to minimize the error. In many cases, LML can guarantee problem solving through its adaptive behavior. If Bragg propagation is expressed as a gradient descent, the algorithm becomes slow and it does not have an optimal solution for that. On the other hand, if Bragg propagation is expressed as Gauss-Newton, the algorithm has the highest probability, which it will give the optimal solution. The next network which was used is Knox neural network. I told you the prediction. The work which right now I will be after this is the I have given you the background. Now I will be discussing about the different applications. So Knox neural network is it is a network which takes place as the weights are being adjusted along the layers. You have you can see from the network input was there, output was there. Now accordingly, the relationship between the input and desired output, weights were adjusted. And the basic model for this is it is a multi-layer perceptron model, and it is widely used in the approximation of non-linear functions that describe complex relationship between independent and dependent variables in many applications. Wherever you have to predict based on the non-linearity of data, you use this Knox neural network because you can say it is widely used for the approximation between non-linear function which describe the complex relationship. The multi-layer perceptron was first introduced to solve the complex classification problem. It has also MLP, you can say classification. You basically go for classification, but because of their universal approximation property, they have been always used as a non-linear regression models and then for time series. Now, identification of the includes the how classifier can identify. They use statistical techniques, and it is not easy to determine the correct architecture because the architecture will depend. You have it is a totally, I told you in beforehand also, it is a totally hit and trial basis. It is a black box where you need to feed your required input to get the desired output. Now these models are by definition over parameterized, and the functions need to be minimized, and which have the many local minima, and implementation is also quite difficult, but for a small thing for prediction it works well. This is the diagram of the non-linear auto-regressive neural network. This is the NARCS we call it, and you can say it can be used to train to predict a time series. From that series, past, follow, whatever prediction you're getting. Again, this is being feed, and it is called feedback layers, and with a time delay. It is used for prediction. This Knox neural network is created and trained in an open loop and which uses the real target value as a response, and it makes sure of greater quality being very close to the true number in training. After the training completion of the training process, the network first it works in open loop. It has both the open loop as well as closed loop. The open loop you have what I have just told you, and in a closed loop the predictive values are used to supply new response input to the network. So Knox is applied for basically it has a major application to the time series forecasting. Now the optimization of I beg your pardon, the optimization of the architecture. What is you everything you need to optimize. So the optimized architecture is always aimed at reducing as much as number of weights and neurons, which will further reduce the complexity of the network. Also, the computational time will be increased and maintain the general capabilities. Now, optimization on the network architecture, we have the two approach. That is number one, the selection approach, and number two, incremental approach. What is your selection in the open loop, and in the incremental approach, you are putting back the data in a closed loop to get the desired output. So selection approach consists of starting the construction of complex network that contains a large network that com- that uh, that contains a large number of neurons, And then this approach is to try to reduce the number of unnecessary neurons and remove the redundant connections during or at the end of the learning. In the incremental approach, we add neurons or layers to attain the optimal architecture. So coming to the implementation. So in the implementation process, what we do is we usually do so just to tell you, just to have a brief what we have discussed about the basics. I would like to say key LV Lerman marketed algorithm, wo it is used to minimize the optimal, it is used to minimize the convergence, that is the error between what would have been the output and what output you are getting, point number one. And Knox is used for the prediction of the data. So time for it consists of two: open loop and closed loop. Open loop till you are feeding the data, and whatever output you are getting, you are again feeding it into the hidden loop to get the desired output. So neural network toolbox you use because let us have now the practical implications, the practical training what we are using. So neural network toolbox, it provides tool for designing, implementing, visualizing, and simulating neural networks. Neural networks are used for application where formal analysis would be difficult or impossible, such as pattern recognition, nonlinear recognition, system identification, and control. Also, it supports feedback neural networks, radial basis, dynamic networks, self-organizing maps, and other proven network paradigm. You can see, if you want to, suppose you have to plot, suppose some of you tell you have been assigned the work to forecast the weather, or suppose you have to you have to decide that you will be given 10 or 15 images and you have to classify it. So it will be a really an Herculean task how to approach. So here you use this neural network toolbox. Now supervised networks are also available in the toolbox, which includes feed-forward, radial basis, LVQ, time delay, non-linear regressive, and layer recurrent unsupervised networks, including self-organizing maps and competitive layers. So neural network toolbox, it includes command line functions, graphical tools for creating, training, and simulating neural networks. Graphical tools, you get a graphical interface. It makes it easy for the neural network to develop neural networks such as data fitting, the time series, pattern recognition, and clustering. And after, when you create the network in the network, you can automatically generate tools to capture your work, and or further you can do the automatic. So this is when you will put NF tool in your workspace, this will open to get the, so that you can start. This is the next, this is the inbuilt. Now this is the pattern recognition, hidden layer, output layer, and you're getting self-organizing map. This is the structure. This is the Knox. This is the next. I told you this is the structure of Knox, how it works. So based on the research work I have carried out, I would like to tell you there, I would like to recommend the following recommendations: that neural network solutions, it should be kept as simple as possible. And for the sake of giving speed, neural network should be applied preferably offline. Also, neural network data set should be collected and it should be divided into training, validation, and testing. This thing, what I have been telling, now I will, in the other slides, I will give you a practical implications. Okay, I will show how it has worked. Neural network fits a solution to complex problems. A pool of candidate solutions should be generated, and the best candidate solutions should be selected using the validation data. And the solution should be represented to allow fast application. Next slide. Now let us start. Now here I have given you the brief description of the neural network. So now let us start. The first thing about the, just a minute, I've got an official call. Now let us see the application of neural network, how I have utilized the application of neural network in locate in identifying the type of faults, also locating the type of fault. So this is so first is for the all the power system engineers who have been sitting there, we know we have transmission system, we have distribution system. So distribution system is nothing, it is the most complex form. You can imagine transmission system, uh, suppose NTPC Badarpur, the power is being generated, or DVC Mathan power is being generated, and it is being transferred. 2 lines, 4 lines is necessary. It is that's all. Distributed system. You are deciding an apartment having 50 flats, having 80 plants, each where the connection is going. So, electrical distribution system is being used. Okay, so this is the electrical distribution system. It is a complex where we have used LV accurate to get the fault. Now, what is faults? Faults, the generalized definition of fault is a fault is defined as the process in which energy is being dissipated in an unintended manner. आपको अपने प्लान किया था, आप डॉक्टर भदौरिया एंड इशिका एंड प्रोफेसर हेमंत ने डिसाइड किया था कि एफडीपी 2:30 स्टार्ट होगा. But due to technical network glitch or due to the glitch of the computer, because my computer was not allowing Microsoft Essential, so this what happened is that FDP started at 3:15. So this is again a technical glitch. So this is a fault. Means energy is being dissipated in an unintended manner. मतलब energy जहाँ पे मिलना था उसके unintended manner में dissipate हुआ. Types of fault. कितने तरह के fault होते हैं? आपको generalize आपने जो भी power system engineers होंगे, you can see there are totally 11 types of fault. Single line to ground fault, AG, BG, CG, ABG, CG, ABG, BCG, AB, ABG, BCG, ACG, ABCG, ABC, ABCB, and CA. So these are the 11 types of faults. मतलब 3 तार का you have the permutation and combination. It can fall down, it can fall somewhere. So depending on this, you can say the you can say the fault can be fault is there. So the nature of the fault can be determined by this. Okay. Now need for fault identification and classification. So for a power system engineer right now, gone are the days, you get a fault, immediately you become restless, you call the engineers, साहब लाइट नहीं आ रही है, क्यों नहीं आ रही है, कैसे नहीं आ रही है, कितना टाइम लगेगा. So think about the lineman. He has to go there, he has to search where the fault has happened, and it takes time, but we are restless. Now we have developed a system where you can be sitting at the substation end, substation the place where you can deliver the fault, and from there, what will happen? From there, you can easily see what is the nature of the fault. एक तार गिरा है, 2 तार गिरा है, 2 तार शॉर्ट किया है, 4 तार शेयर किया है, शॉर्ट किया है. You can classify the type of fault. You can identify where the fault has happened, and also you can locate the fault where the fault has happened at a very minimal, you can say, very minimal error. मान लो आप सिटिंग बैठे हो एबीएस में और फॉल्ट आपके मेन गेट पे, आपके इंजीनियरिंग कॉलेज के मेन गेट पे हो गया, तो आप बैठे बैठे सब स्टेशन में यू कैन आइडेंटिफाई द इंजीनियर्स, यू कैन से द प्रोडक्शन इंजीनियर्स, they are able to visualize where it has happened. So this is an attempt to, we are using the neural network and signal processing tools. It was an attempt was made to locate this supply, and for any algorithm, whatever algorithm we made, 2 network system was taken, the Sasken power distribution network and the IEEE 13 node feeder. They were taken to validate the fault. Fault कैसे इसको validate करते हो. Now next. This is the Saskatchewan. ये आपको मैंने बताया था. This is the Canadian power system जिसपे काफी काम हुआ था Saskatchewan यूनिवर्सिटी में. And this is the Canadian power system where lot of work was done to elaborate to find the fault, and then also this is the zone 1, 1 to 4 was a different locality. Zone 2 was 5, 6, this is a different locality. Zone 3 was 7 to 12, a different locality. Zone 4 was 14, 15, 16, the different. Zone 5 means they are a different basically area. And the stretch was 38 kilometers. I, in my work, has been able to find the locate the fault for 38 kilometers. Okay. Now this is the IEEE 13 node feeder. This is the standard system which the IEEE people has developed, that you whatever algorithm you tell, okay, accepted, but you need to test on this. And I was successful on testing on this algorithm. Now these are the simple classification. This is the analogy we use. This is the combination we use, that if we want to classify the fault, this is the number of misclassified sample, total number of sample, this was the error percentage, and location was distance calculated, and what was the actual distance, and whatever we get, that was the error. So basically these are the methods which were used. Impedance based method was used. We used to calculate the line impedance and then calculate. This was a very primitive method. Then with the advancement of time, traveling wave methods you came. That is light travel with the speed of the using incorporating the velocity of light, you were able to identify the fault. Then the knowledge based methods, what we talk right now, recent ANN and all those things. Then the hybrid based methods. So I will just simply move on because of the shortage of time. I had prepared a lot of slides, but I will just shortly move on. The wavelet and wavelet, I will just take example of wavelet and wavelet packet transform based features. What happened is, discrete wavelet transform. In short, I will just tell you that fault was created. A database was being generated. You can see in the forward. See, these are number of cells. Total, you can see for the sample 1, 768 database was created. For sample 1, sorry, I beg your pardon, 73107 samples were created. For sample 2, that is the IEEE 13 node forwarder, this is the IEEE 37 kilometer feeder, 310 samples. For sample 2, 768 features are connected, and at the 16 Hz frequency, this was being calculated. And these are the parameters we have set. The mean square error should be 0.1 into 10 raised to the power minus 6. This is the mean of square error permissible for my work. Number of epochs. Epochs means the iterations. The iterations for classification was to set at 2000s, that you have to iterate in order to get this mean square error. The maximum error permissible was 0.10, 1 is to 10 to 10 to power minus 6. For location 3000. So 30% of the data was used for training. Whatever network we have created, I have told you, you can see from this slide, whatever the database was created, about 4,000 samples, 4,000 current signals were captured for the analysis. And for this, you can say 30% was used in training and 75% was used testing. And one of the most interesting topic for the power system engineers and electronics engineers watching this FTP is that less than quarter of the full cycle data was being utilized. Less than quarter. मतलब एक cycle waveform जो होता है, आप मान लो 50 Hz frequency का there is a one cycle. In one cycle, only 25% of the data the fault was considered. Now, this was the algorithm which we developed. First, we had synchronized the moving window for phase current IABC. Then these wavelet and wavelet packet were concerned. Then we calculated E. These are the algorithm we discovered. We calculated the E using the standard absolute voltage of weighted packet coefficient. Then feature matrix input. Now, what is feature correction? This is a very important point which one you would use. Now, when you consider the 4,000 samples, 4,000 samples consist of all 11 types of fault for different range of resistors. But as an computer engineer, as an electrical engineer or as a computer engineer, when you observe on it, what you will find is that these faults will have a different patterns. They will have the fault will have the different patterns. So these patterns needs to be justified. So आप एक पैटर्न का मान लो 50 ओम्स में कुछ और पैटर्न है, 60 ओम में कुछ और पैटर्न है, तो आपको उस पैटर्न को करने के लिए आपको you should give you should make the system understandable कि अगर इस तरह का फॉल्ट होगा तो ये आउटपुट होगा, अगर इस तरह का फॉल्ट होगा तो आपको ये आउटपुट मिलेगा. So this was being used for getting the for detection of fault and location for getting the database. You can see the error percentage using wavelet transform was 0.38 percentage. 4000 सैंपल जो हमने लिया था, जो हमने डिफरेंट टाइप से फॉल्ट का लिया था, जब हमने वेवलेट पैकेट ट्रांसफॉर्म यूज किया, DV1 फीचर इसका एक फीचर होता है, तो यूजिंग न्यूरल नेटवर्क आई वांट टू से, तो ओनली 0.3875 percentage of samples misclassified, and these were the all different sections in depth results. You can say wavelet packet transform for getting the features. Features मतलब होता है आप you use the different signal processing tool to reduce the feature. मतलब आप feature मतलब कि जो भी आपका logical information है उसको capture करने को हम कहते हैं feature extraction. So these were the different feature extraction. So you can see different DV1 use करके different section जो आपने बताया था, पहला वाला का सिर्फ 1% एरर था सेक्शन 3 में, अदरवाइज बड़ा अच्छा था. ठीक है. Now moving to next. So for the section 2, now SG2, you can say this is the distance correct. This was distance in meters. So error distance in meter was calculated. You can see out of 37 kilometer, 37 kilometer का, sorry, I will just take this one. This is the section 1 location result. आपका जो एवरेज एरर था इट इज 0.161, 0.001, 0.288. That means the person sitting at the substation end was able to recognize the fault. He was very much able to recognize the fault sitting at the substation end. तो उससे वो दिस इज द एप्लीकेशन ऑफ न्यूरल नेटवर्क. वी हैव फेच द डाटा. तो हमने वेवलेट ट्रांसफॉर्म में वेवलेट फीचर क्या होता है कि मान लो आपका 4000 का मैट्रिक्स बना आपका, तो फीचर मींस द फीचर एक्सट्रैक्ट मींस द यूजफुल इंफॉर्मेशन कंटेंट एंड द सिग्नल इज यूज्ड टू फेड द न्यूरल नेटवर्क कि आपको ऑप्टिमल रिजल्ट मिल जाए. तो हमने जब वेवलेट ट्रांसफॉर्म या वेवलेट पैकेट ट्रांसफॉर्म यूज किया तो वी वर एबल टू एक्सट्रैक्ट द यूजफुल इंफॉर्मेशन टू गेट द डिजायर्ड रिजल्ट्स. तो हमने वो फीचर्स मतलब हमने वो 4000 मैट्रिक्स या जितना भी बड़ा मैट्रिक्स था उसको रिड्यूस किया कि हमने ये वेवलेट पैकेट और वेवलेट ट्रांसफॉर्म देख के हमने देखा कि ये जो सिग्नल प्रोसेसिंग टूल्स हैं इनसे हमने जो इंफॉर्मेशन था उसको हमने एक्सट्रैक्ट करके हमने फीड किया न्यूरल नेटवर्क टू गेट द डिजायर्ड आउटपुट. दिस इज द एरर्स, दिस इज द लोकेशन. ठीक है, फॉर 1 and 2 these are the location for different zones. Now you can say the whole neural network, this was the time taken for the feature extraction. In MATLAB, this was the mark carried on in MATLAB. You can say the time taken in millisecond. Whatever is the size of the matrix, whatever is the size, this was the only time taken. है ना? So in order to get the desired output for feature extraction 3.35, it is not a part of neural network, but here you can say here is the where the neural network plays the prominent role. 11.28, 2.54, 18.29. So this is the place where neural network took the prominent role, and this is the for wavelet transform, packet transform. This is the feature extraction where the useful information was extracted, and for identification, classification, and location, this is the time taken in a millisecond using the computer. Obviously, this will depend upon the different computer signals you have taken. Now we have different GABA transform based features were considered. I gave you example of neural network utilization. I will just show you the results. See, this was the algorithm after GABA we determined the RARB RPC what was used, and then it was fed to neural network for fault classification and fault location. And I will see the You will see just the result, the classification results. Very much promising Gabor transform, very much promising. But our area is now today neural network. So see the results, minus 4.1. Here the minus sign denotes, suppose the fault occurred at distance A. So minus occurred at 4.19 meter before the distance A. The engineer can see the fault using the algorithm. So these are the different results. We have compared the results. Okay. Now just because of the shortage of time, I am just so see, you can see the computation time. Gabor taken from this is where the neuron after see for feature extraction for one feature it took 2.25.96 millisecond, but after the feature we extracted, this is the time in millisecond which was used for the identification, classification, and location of faults. And then will be again different features extracted to get the results. In some part, after extracting a feature, mean, square, square was determined for the fault classification and location. Just to hurry up, because I don't want to waste, because other things are there. Then we had the, just a moment, see the computational time for these features. Then also we have used duality complex wavelet based features to get the property. So what I mean to say is that neural network, apart from rather than feeding the direct data, it is advisable that you use some signal processing tools in case of power system faults to extract the features and fed it to neural network so that also your computational time is saved, you get a proper result, and feature extraction, I told you, it is a prominent method for getting the desired output. तो आपको ये करना चाहिए जब भी आप जिस तरह का आइडेंटिफिकेशन और क्लासिफिकेशन ऑफ फॉल्ट करोगे तो आपको फीचर एक्सट्रैक्शन प्लेज अ प्रोमिनेंट रोल हियर माय फ्रेंड्स my faculty colleagues, I would like to mention one thing. This is the basic difference between a neural network and deep learning is this thing only. In deep learning, what happens is in deep learning, you need not go for feature extraction. But in neural network, you have it is always highly recommendable to get for this data. So this is the first slide. Now this was you can see for the signal. This was the one dimensional. Okay. Now I will tell about the weather prediction. Now some other work, some other employment. I will just try to finish it as fast as possible. So weather prediction. Just a moment. I will open my different slide. Just a moment. Vikas? That share option, just a minute. Now it is okay. Actually, that was the problem. Just share option. I think how to maximize my slide. Take that. Huh. Now second work. Just I am sharing my second slide. Is it visible? The slide is visible. Just a moment. Vikas, can you do me a favor? Can you open a second slide for me? Vikas, Vikas, something is happening. So will you start without wasting the smart cities? Open the slide Smart Cities Delhi. You download these three slides. Okay. Hotspot FDP, Smart Cities Delhi. Am I visible?
Yes, sir, you are visible.
Ishika, do me a favor. Open, download the slide Smart Cities Delhi. Okay, okay. Ah, not sharing started. Again, problem is coming. Just download all the next three sites. I will try to wind up. It is a very interesting topic. I have clicked the option. So, moving forward, right now we have done how to deal with the 1D problems. So, now moving forward, now I am going to tell you about the ANN. We have used this ANN for predicting the PM 2.5. As you know, people residing in the NCR region, people residing in the parts, pollution is one of the most prominent, you can say pollution is one of the most prominent, you can say, the thing to be tackled. So every day we open our app, what is the PM 2.5 particulate matter 2.5 in the atmosphere? So we are using this ANN. We have developed this ANN, and this paper was published in the Springer also. Just a moment. Vikas, please download the our next three slides. Okay. Let me reboot my connection just a moment. Moving forward with the no problem. Tell her to share the first ANN based prediction for PM 2.5 for Delhi. Tell her to, in the meanwhile, tell her to download all these three slides and tell her to share first ANN based prediction. The Vikas, in the meantime, allow me to share also.
Sir, just give me a minute. I'm downloading the files.
Okay, okay.
Sorry, sir.
No, no problem, no problem. So, just I will tell you that, just I will give you a brief account that pollution is defined. Pollution is one of the prominent issue, and pollution is, it is defined as the, you can say, debasement of physical and biological components of the environment. Any substance which is present in such a concentration that has an adverse effect on the environment, public and property, may be termed as pollutant. Anything which is going to adverse, which has an adverse effect, can be defined and termed as pollution. I think it started.
Sir, which slide do you have to show first?
What you have done? Ishika, download the slides for that pollution.
Sir, I've downloaded all the files. Like there are 4 files: Smart City, Hotspot.
First one is committed. You open that smart city.
Uh, okay, I've opened that.
Indian waste protection for PM 2.5.
Yes, sir.
Okay. So is it visible to everyone?
No, sir, it's not visible.
Ma'am, I'm just.
Acha, nothing is visible to me.
Visible, sir, visible.
Shall I start? Shall I continue further? But I am unable
Yes,
to
sir.
see any presentation. So which slide you have opened, Ishika?
Sir, this is the first slide, ANN based prediction, Smart City.
For PM 2.5 for Delhi.
Yes, sir.
Ishika, the presentation
Yes,
title
sir.
is ANN based prediction for PM 2.5 for Delhi. Is it so?
Yes, sir.
Okay, let me proceed now. Now we'll move to second slide number 2. So you know that pollution, as I told you, that any substance which is present in such a concentration that has an adverse effect on the environment can be termed as pollutant. So the WHO, it has laid down certain standards, it has governed certain standards for the pollution. Now these guidelines describe the maximum concentration of pollutant that is present in the environment, which is permissible by the, which can be easily bearable by the human health. Now, the United States Environment, you can say United States Environmental Protection Agency has introduced the National Ambient Air Quality Standards. As an electrical engineer, we have IEEE. So the pollutants, they have this National Air Ambient Air Quality Standards. So these standards have defined the permissible limit. So which consists of the particulate matters PM 2.5, PM 10, oxides of sulfur and nitrogen, carbon monoxide, ozone, and lead, that is not going to have a very much adverse effect on our system. Now, with the growth of rapid industrialization and urbanization, the air pollution has been on the verge of global rise. So, you have been listening to this. You have been see. This is the Ishika. Move to slide number 3. So you can see from the slide, transport and traffic for the government has been focusing on smart cities. So what was these smart cities? Ishika, move to slide number 3.
Sir, I'm on slide number 3, air pollution introduction.
हाँ ठीक है. No, that is slide number 4. You move to slide number 3. So, see, the government has been focusing on developing of smart cities. We need smart cities. Ah,
Sir, let me check once again. I'll reshare it. Sir, is my slide now visible? Okay, sir.
ah. I think my slide is also, I'm also able to share now. But Ishika, you keep the background. So moving to slide number 3. So I have told you that smart city is the proposal of each and every government. So we should have an able to develop the sustainable policies. We should have a able transport, traffic and transport system. We should have a able waste management system, water supply system, power plants, hospital, schools, and community to get this. But if you look further, these systems can be developed, but with the COVID, with the COVID pandemic, and doctors saying that a PM 2.5 has a greater amount of concentration. So air pollution has causes a global threat to our inhabitants' health. So what we have done, so as per the NACS, the air pollution modeling was done. So in the present work, what was done was an attempt was made to develop an AI-based model, prediction model. The meteorological parameters such as temperature, vertical wind speed, wind direction, solar radiation, relative humidity, and wind speed they have been utilized for predicting the PM 2.5 concentration present in the air. We were also successful in developing the algorithm which was able to forecast the PM 2.5 concentration. And first, in this work, we were able to forecast 1 day ahead prediction. Suppose if you use my algorithm based on the database provided by the meteorological data, you can very easily say what on 18th December, this can be the PM 2.5 concentration. And then you need not have to use any application. So this was the work. So various work was considered. So I will just skip this. Okay, just a moment. So I will just skip these various. So this is the study area which we consider because New Delhi, it is the epicenter of pollution. So Delhi, the national capital of India, it is the one of the busiest metropolitan city of the country. And it is very shocking to know that it has been ranked sixth among the metropolitan cities of the world in terms of economic growth and in north it and pollution. Delhi is located in the between the latitudes, you can say, at 28 degrees 24 minutes 17 seconds and 28 degrees 53 minutes 0 second north and longitudes of 76 degrees 50 minutes 24 second and 77 degrees 20 minutes 37 seconds east. It has Delhi has a total area of 140 square kilometers, and as per royal census, the population of the city was 1.9 crores. Now, the air quality seems to deteriorate in the winter season. Now, the Central Pollution Control Board, which is a statutory body in the India, in our country, it is responsible for the monitoring of ambient air quality across the country. So what we did, we took the 24-hour data which has been collected for the six stations. These are the six places: Chadipur, RK Puram, Mandir Marg, Dilshad Garden, and D2, from where we collected the data, and we were able to predict the PM 2.5 concentration using artificial neural network, in which with the data included wind speed, wind direction, temperature, solar radiation, relative humidity, vertical wind speed, respectively. Now, if you look at the figure, these were the coordinates taken. Now, these were the methodology which we have adopted in order to get a data. So this was the data set 24-hour data set, which was taken from the Central Pollution Board, and these are the data: vertical wind speed, wind direction, temperature, solar radiation, relative humidity, wind speed, and PM 2.5 concentration was concentrated. And then since these are very typical non-linear data, so these data were normalized. And for as I have already told you about the basic, you can say basic structure of ANN, we have used the Knox network for ANN modeling. From there, we were able, whatever the output we got, we received the coefficient of correlation, the mean square error, and root mean square error. And these three coefficients, which is also used for sensitivity analysis, were able to predict the PM 2.5. Actually, the R value. So this is I told you, this is the non-linear regressive network. These are the data which are given a time delay. We are getting YT. Now this was again feed in the feed forward network to get the optimal output, desired output. Also, these are the sensitivity element parameters which were designed here. The coefficient correlation was used, you can say, where you can see R is equals to Q naught. Here is the observed concentration. M naught refers to the mean of observed concentration. QP is the estimated concentration. MP is the mean of estimated concentration. For mean square error, again this was reviewed and root mean square error was evaluated. Now, the results, we have used the Knox network, and the results were further compared. This is the result, you can say, for the proposed model. You can say the proposed predictions were very good at the R, because it is the R value, the regression value, which determines the concentration. It was very good as predicted before using the Knox network. So here you can see from the diagram, 80-10-10 is written, means 80% of data was used for training, and rest there's 10 for validation and testing. Similarly, for the other 17-15-15. In all the concentrations, because our main aim was to reduce the data, so we were able to fetch a good result. So for the ANN architecture taken for 17-15-15 and 80-10-10, these were the results obtained. And this is the size of neuron. Actually, what we did in this work is that from 1 neuron to 100 neuron, we calculated the result. What can be the result? And the optimal results, for getting the R value and MSC and RMSC value, the optimal result, I told you, neural network is totally a hit and trial basis. So optimal result for D2 was got at 65, Mandir Marg at 75, Dilshad Garden at 25, 100 Shadipur, and RKP. This is RK Puram at 25. This is for the 17-15-15 and 80-10-10. This was the architecture proposed. So also what we did, we were able to predict 1 day in advance during this algorithm. So again, I will slide and I will share another work. Just a moment. Here we were able to get this prediction for 1 day in advance. Now, just a moment. Vikas, Vikas, just a moment. The share option is not coming.
Okay, sir.
Open that slide, hotspot FDP,
Okay, sir.
and directly come to slide number 5. Okay, just a moment. I have stopped. Have I stopped?
Sir, slide number?
5.
Okay. Sir, is it visible?
Vikas, is it visible? Okay, okay.
Sir, check once if it is visible. Okay.
So, Ishika, moving to slide number 5. So, my friends, right now we are dealing with the prediction of the PM 2.5 concentration using Knox network, and here in the previous we were able to predict for 1 day. So here in the another study, what we did is that we took the residential and industrial area Patparganj and Anand. We had 4 different areas were taken, and in which 2 was residential, 1 was industrial, and Anand Vihar, as you know, it is used for the mixed purpose. The same methodology was adopted. Ishita, move to slide number 6. Ishika, slide number 6.
Yes, sir, I'm showing slide 6. That is methodology.
Yes. So here you can see, apart from the previous work which we have done, we have included the pressure also. The pressure was also provided by the board. Now, after interpolation and normalization, what we find is there in that case, we have used just the Knox network. Here, in order to prove the efficacy and prove the effectiveness of our algorithm, we utilize the feed forward backpropagation, recurrent neural network, Elman network, and Knox for getting the result. And Ishika, slide number 8. I would like to just say here also, even a comparative study was shown for different 4 algorithms. Here also, Knox provided us the optimal result in you can say Knox gave the optimal result if compared to the FFBP, RNN, or Elman network, feed forward network, or recurrent network, or Elman network. So here it was our observation. Here we concluded. Ishika, move to slide number 10. Here, Ishika, move to slide number 10. So here I concluded for the time series prediction, as it was mentioned in literature, Knox network is the optimal network to get the desired result. Just I want to say, Knox network is the optimal result for getting the desired result. Is it visible, everyone, to slide number 10?
Yes, sir. Yes, sir.
So you can see in the result also 0.907 RK Puram regression, 0.90449, 0.907. It is means the regression value should be teaching the 1 and mean square error should be less. So NARC network, if compared to the other networks, as proved in the literature, proved to be the worthy prediction algorithm. Now, in my dear friends, due to shortage of time and due to the network issue, I told you these two, the prediction and the classification, it was taken almost the one-dimensional network was taken into you can say one-dimensional network was considered. Ishika, just close this slide presentation.
Okay, sir.
Now, moving to the two-dimensional presentation. Moving to the two-dimensional presentation, that is Weld image. I will just take your 5 minutes, last 5 minutes, and I will try to wind up. Now, Weld images, just I will give you a background. It is very obvious that we have been doing welding, no problem. But I would like to bring to your kind notice that there right now with the advancement of Shita, please please your presentation.
Okay, sir.
I'm trying to share the slide, otherwise you say ha. Yes, okay, I'm able to share the slide. So this is the up till now what we have discussed is the one dimensional. Is it visible to everyone? Visible?
Yes, sir.
Yes.
So now in the last two work, one dimensional was used, means one dimensional data was used. Moving ahead, now moving again, playing with the neural network. Feature extraction techniques do play a greater role. What happens in radiographic weld images is you have already heard about the interesting NDT. Now I will tell you the interesting technology why we have done this work is. You know, buildings are being, and right now builders make the building. Okay. Now what happens is, suppose Mr. X builder, he has been a poor builder. What he will do is, he will have the labor will have some welding defect and they will start the structure. So you have the two testing now. Now, for suppose you come and you find something fishy, or somebody informs you, some of the labor informs you, कि भाई, this builder has used the low technology or low technology in types of welding defects. So what you did is that you employed, now it is you become tensed. So the scientists developed the non-destructive tensor the testing mechanism, that is NDT. In NDT, what happens is that without opening the without playing with the without destructing the features, you are able to recognize. So one is traveling waves. You send the traveling waves, and if your traveling waves are reflected, you get the optimal solution. But that equipment is cost around 32 lakhs. So what was done is, from BEL and IIT Roorkee, radiographic weld images were taken into consideration. I will just come to the because of the lack of time, it was taken into consideration. Now these are the types of flaws that occur in a weld image. These are types of flaws that sustain in a system. Wormhole, linear slack, gas, depending on a different pressure, different moisture, and different content. So lot of work has been carried out. So see, these are the sample image database with the you can say gas cavity, lack of penetration, porosity, slag inclusion, crack, and lack of fusion, wormhole, and underground. This was the lack of database, uh, which was the types of flaws which existed in a welding system. So what we have done, I will just tell you that these are the some feature extraction techniques, but ultimately we have employed neural network for classification. See, these on the next test, I will show you this result. That's it. These are the different feature extraction techniques to get the appropriate feature for getting the classification done. The image, the 2D image was converted into 1D signal, or you can say 1D Excel file. And then after extracting the features, feature extraction means you are getting the relevant information that is going to give you the desired output. These many techniques were played upon: GLCM, GLRM, LBP, linear binary pattern, linear, then ALP, binary gapper pattern. And these three, leave SPM, leave out leave SPM, SPM different, RBF kernel and artificial neural network was obtained. You can see the ANN in my case in this radiographic field image has fetched you a very good result as compared to the, you can see these are the feature extraction, and also with 80-20 architecture and 70-70, 80 training for training, 20 for testing, 70 for training, 30 for testing. So these are the result, you can say 91 point. If you can compare with the Leave SVM or RBF kernel SVM, ANN proved worthy. Though I just conclude, because of shortest time, I just conclude that neural network has got a wide range of, it has got a wide range of application, and which can be used for 1D, it can be used for 2D, it can be used for different dimensionals. And one must not, it is a humble advice to faculty members, if you have a large database, if you have a large amount of database, then you should go for deep learning. Otherwise, try to prove the worthiness, the effectiveness on neural network, then you switch over to any other deep learning. Deep learning, the advantages I am telling you, you need a high network, number one. Number two, the feature structure problem is solved. So those who have been working on 1D or on power signals, or they want to predict about their state, about their district, about the pollution, you can predict. We have done only PM 2.5. You can predict PM 10. You can predict the concentration of carbon monoxide. You can do the concentration of the lead, anything, any pollutants present in the, and all the data which is provided by the central board for this data verification. So 1D, 2D structure can be used, the ANN can be effectively used if you have a proper feature extraction technique for getting the optimal result. So I have taken 20 minutes more, but I conclude my presentation that neural network in the present day scenario is one of the most optimal technique. And if anyone wants to work with me on these three areas, they can indirectly contact me. Vikas is there. My email ID will be shared. So thank you, Vikas. Thank you, Professor Hemant. Thank you, Shikan. Thank you, all participants. Any question? विकास एक स्क्रीनशॉट ले लेना है ना. Okay, thank you. So kind of you. Thank you. Thank you, Vikas. Thank you, Dr. Vikas. Thank you, Ishika. Thank you, Professor Hemant. Thank you, the Honorable Chairperson, Honorable President of ABS. Thank you, AICT, for giving us the opportunity. Thank you very much. Right. Any questions? Any question, participants? I had to deliver a talk on fault. That's why fault occurred. Now every screen is being shared, everything happened. Actually, the thing was that computer was not allowing Microsoft as in the team. It was not a network issue.
Hello, sir. Good afternoon.
So
Hello.
kind of you.
Sir, I would like to ask one question, sir.
Ah.
Sir, the session was actually very helpful and very informative. I have one question, that is Levenberg-Marquardt algorithm you said, no, sir?
Yes, sir, ma'am.
That is suitable for small non-linear problems or linear problems?
Actually, what we have done in our case, we have utilized for non-linear. Okay.
Yes.
Linear
Yes.
is for anything. And I have in my personal work up to 20 to 25,000 data.
Okay.
I have been easily validating it if you have a good workstation with you. And for nonlinear parameters also, my data was, I told you, the faults, they were nonlinear. And even in some papers I have found 1 lakh or 2 lakh samples were taken and they were utilized.
Okay. Okay, sir. Right, sir. Right.
Thank you. So kind of you.
Thank you, sir.
Thank you, Vikas. Thank you. No, I have to. I have prepared my presentation. See, technical. This is our field. We cannot run away. We should not run away. Actually, if time would have permitted, if network would have permitted, 1 hour or more, I would have taken. No problem for that. Thank you, Vikas. So kind of. Just I would like to extend thanks to my dear friend Dr. Jayant Kumar that we have been working together. He's an assistant professor at NIT Jamshedpur, and also Maninder Kaur, she's the head of civil department. We have been working together. Thank you so kind. I'd like to extend a warmful thanks to them. Thank you so much. Okay, thank you. So nice of you.